Hey everybody, this is a recap of the heat transfer investigation at home lab from today and yesterday. Just wanted to go over a few key points here on the lab. I'm going to use the answer key so that you can see some of the correct answers and you can compare the things that you wrote with what's on the answer key. The first thing we wanted to go over with you are the definitions of the three types of heat transfer. A lot of you had some awesome definitions, but I'm not really sure you understood what you wrote down. Let's look at some very simple ways to remember these three types of heat transfer: conduction, convection, and radiation. Conduction is direct contact. Here's another at-home lab you could do. Put 3 different spoons in hot water and see which one conducts heat the best. Is it the metal spoon, the wooden spoon, or the plastic spoon? All 3 of these things are conducting heat or doing a heat transfer through direct contact with the hot water. Convection's another type of heat transfer where there are some currents involved. There's a constant source of heat, like in this hot air balloon, there's a constant source of heat down at the bottom, heating the air, decreasing the density, which causes that hot air to rise up. It'll cool down at the top and then fall to the bottom, where it'll get heated again. It'll rise up, cool down, and fall. This continuous movement of hot and cool air is a convection current. And then lastly, it's radiation. Radiation is just the transfer of heat through space. Unlike sound, heat can actually transfer through outer space. It does not need air particles to transfer its energy. It can go right through a vacuum like outer space. You probably remember us talking about this when we did the electromagnetic spectrum back in the first 9 weeks. Okay, after you look at those 3 things again, I asked you to walk around your house and try to find areas in your house where you'll see radiation, conduction, and convection. I used my fireplace as the example. Heat starts inside behind the glass and then it radiates throughout the room. It's not direct contact. Nobody is touching the fireplace. It's just radiating through the room. Conduction, I used a grill picture. The grate on the grill gets very hot and then transfers the heat to the bun that's placed in direct contact with the grill. And then lastly, I found a tea kettle as my convection example. The constant source of heat is is on the stove. It's heating the water at the bottom of the tea kettle. That decreases the density of the water, causing the hot water to rise up in the tea kettle. It'll cool off and fall back down and then be reheated and rise up, and it continually moves inside the tea kettle, causing a convection current. Looking at all 3 of these examples in your house and the examples that I gave you on this particular document, the big idea here I hope you could see is heat travels from hot to cold. In all of those examples, it's going from the hotter object to the colder object, and that'll continue to happen whether you're talking about conduction, convection, or radiation. The last part of your lab was looking through some different examples, different pictures. You can see here in this picture, we've got conduction and convection happening. Conduction's where the pot is touching the hot coils on the stove. Convection happens inside the pot where the warm water is getting heated up. It's rising to the top and falling, forming a convection current. Here's a picture of radiation, someone warming their hands with the heat that's radiating or traveling from the fire. A hair dryer is also a source of radiation. The hot air inside the hair dryer radiates out. Same with the toaster. The toast doesn't actually touch the hot coils inside. It just cooks by radiation. Here's a tea kettle example again with those convection currents drawn in. And then conduction. This girl is holding a hot cup of tea, and that's a direct contact, so it's conduction. The last question here was asking you about where you might research convection under the Earth's surface happening. And I also put a picture here to look at the comparison between the hot water on the stove and the convection happening in the mantle, which is a layer of the Earth. Both of these pictures have a constant heat source, the stove or the core. In both cases, it's heating a liquid. It's water on the stove, or it's this liquid rock in the mantle layer of Earth, causing that to become less dense, which makes it rise up. As it cools down, it falls back toward the core of the Earth, and this continues to happen over and over again. I hope that helped you understand part of the heat transfer lab, and we're looking forward to some more investigations with convection and the layers of the Earth.